Assalamualaikum warahmatullahi taala wabarakatuh. How are you? Everybody okay?
Waalaikumsalam. Alhamdulillah.
All right,
Okay,
good.
so far.
Okay, today we're going to move on. We're going to start with chapter number 13. Now, chapter number 13 is on definite integral. It's an extension of chapter number 12. So based on the concept, all right, the idea of integration that we learned in chapter 12, we can do, or we can go one step further. We're going to do the definite integral. We will start with we start with 13.2. So we skip to 13.1 because 13.1 is the theoretical part, which is not really relevant to us. So we will do the 13.2 to start with. Now, what is a definite integral? What is a definite integral? Now, definite integral is when you take integration or when you do integration of a function within a specified intervals. So we consider, like 2 points, x1, x2. Of course, x1, y1, x2, y2. But we need only look at the area, the value of x for that interval. So let's say x1, and x2. So we are going to look at the integration of a function between the 2 points. We call it over the interval. So that is definite integral. Okay, so we're going to do integration given 2 points. So we're going to evaluate the integration between the 2 points. So that's the idea. Now let's look at more detail, on the discussion. So let me just start with definition of definite integral. So we're going to define. Okay, we're going to define what is the definite integral. So the idea is, like I said, we're going to evaluate the integration for or given the 2 points or between 2 points within the interval. So graphically it would be like this. So let's say, we are looking at a function y equal to f of x, and then we are looking at the interval, say x1 equal to a to x2 equal to b. Of course, for x1 you can find the value of y1, and then for x2 you can also look at y2, but we just look at the value of x. So graphically, it will be something like this. You got the graph x, y here, 0. Let's say the curve look like this, y equal to f of x. And we're looking at the value, okay, x1 equal to a, so we call it a. And then you got the value here, x2 equal to b. And of course, we may add b bigger than a, b bigger or equal to a. So that's the interval. So the interval, we call it AB. So AB means the interval AB. Interval AB. Now, when you have a bracket like this, okay, like a square bracket, that means the endpoints is included. Endpoints included in the interval. So the point A, okay, is in the interval. Point B is also in the interval, and of course, every other point in between will be in the interval. So we show it by the straight line like this, non-broken. If you have the interval like that, okay, in other words, a regular bracket, the endpoints excluded. Okay, so here you got A, B are not in the interval, are excluded. You show it by broken line, like what we were doing for the inequalities. But for the definite integral, in order for us to find the integration, we assume that the endpoints are included. So we call it that interval AB. Okay, we did not write it. So this is what we are doing. All right. So definite integral is essentially like you're going to evaluate the integral f of x, which is the integral of f of x dx the interval in AB. Okay. All right. So that's the idea. So now, what is it? So let us write the definition. So based on our discussion here, we are going to define the definite integral. So for a function y equal to f of x, so given a function y equal to f of x, and the interval, okay, interval ab over the the values of x1 and y1, such that we can say that b is bigger or equal to a, then the definite integral is equal to the following. Then your definite integral, I think everything here is given in point. Definite integral f, right, of f. Okay, I'm going to write y equal to f of x. We can use either y or we can use f of x. Y equal to f of x over the interval over the interval AB over interval AB lah. Okay, or from A to B. Okay, from A to B is given by the following. The notation, okay, we write it, the integral of f of x dx from A to B. So you write A at the bottom, B on the top. So that means we are going to evaluate, okay? We are going to evaluate the function, or the integral of the function from the point A to point B, okay? And that is equal to the integral of f of x is capital F plus C. Okay, that's the integral of f of x. Now, when you evaluate from point A to B, point A, x equal to A or x equal to B, or you can say from A to B, or you can say point A to point B, we do it like this. Okay, straight line, vertical, A on the bottom, B on the top. Now, I say evaluate. Okay, when you evaluate, it means you're going to get a value. So that will be equal to the value of the integral at B, which is x equal to B, plus C, minus the value of the integral at the initial point A, plus C. Now, as you can see, the C and C will cancel out. So what you have left will be f of B minus f A. So that is definite integral. It's simply the value of the integral of f of x at B minus the value of the integral of f at a. Okay, and what is it? It's going to be a value. Okay, so you will get some value. You call it, say, whatever you want, call a. Okay, so when you do that thing, what you will have is, after you do the evaluation of the integral at b and a, you will subtract. What we'll get will be the area. So you call it a. So what the area under the curve. So call it area a. So I call it a, and that a is the area under what? Under f of x between a to b. So I show that by the shaded region. Shaded region in the graph. Go back to the graph. That will be the area that we're talking about. All right. So definite integral between 2 points within an interval a, b is what? Is essentially the area under the curve between a and b. Okay, it's the area under the curve between a and b. So how do we do it? We integrate the function, evaluate the integral at b, and then we evaluate the integral at a, subtract. So what you get will be the definite integral from a to b, which is what? Which is the area under the curve from between a and b. Okay, you got the idea? Any question? Anything? Okay, if you have a problem, you have any concern, let me know. Okay, so there is nothing difficult, okay? Nothing much. It's an extension of what we have learned. So the new thing is we evaluate the function or the integral at b, evaluate at a, subtract. All right, and that will be what? That will be the area under f of x between the 2 points. Okay, all right. So let's look at a few examples. So if you look at example 13.2, there are a few examples. So based on that example, we will do a few. Okay, so let's say you want to find the integral from point 0 to point 3 of 2x dx. All right, so I want to find the integral here. So when you see this symbol, then we know it is a definite integral. So what do we do? So I write down the question, right? Find the integral, okay, of f of x equal to 2x from 0 to 3, or for the interval 0, 3. So graphically, okay, the idea is you look at the graph. Sometimes it's good, you know, that you sketch the graph so that we will get an idea of what we're talking about. Now, what is the graph 2x? Of course, you know, we're talking about simple function now. You know, if the function is something beyond our level, then don't worry about it. The function that we already learned, we know basically how the curve look like. All right, 2x, how does the curve look like? Anybody still remember? Hello, hello, hello. 2x, how does the line look like?
Straight horizontal line.
Y equal to 2x, horizontal line ke?
Oh, sorry, sana.
Ayo, cepat-cepat ni final exam coming ni, takkan dah lupa. How does it look like? Hello, hello. Cepat. Okay, Zaki, how does it look like? Zaki ni. How does it look like? Y equal to 2x. The line. Okay, Putri Rashidah. Dah balik raya naik bas kan? Sekarang dah balik UAE ke kat Johor lagi? Hello. Y equal to 2x. Takkan lupa. Okay, cepat. Anybody? Putri. Okay, Irfan. Siapa-siapa lah. Cepat. Y equal to 2x. You know, the simplest function. How does it look like?
That is slope. Slope.
Slope berapa? What is the slope? Just tell me how the line is.
Upward slope from left to right.
Upward slope left to right. How does the line look like?
Straight line.
Straight line. You know, straight line slope is equal to what? What is the slope?
Y equals to 2x.
The slope is 2. What is the intercept?
0.
Intercept 0. So y equal to 2x, you know, slope is positive 2, going left to right, intercept at 0, will be like that. When you have y equal to 2x, janganlah lukis kat atas ni. Okay? Jangan buat sini, salah. Okay? So when you do this, I want you to sketch, but of course, we have to be right lah on the intercept. Okay, and of course, if it is a linear function, that will be a straight line, and it cuts the origin. So we are talking about from x equal to 0, which is that point, to 3. So that is the definite integral we are looking at. That means the area here. So that is the area A. So, you know, sometimes for convenience, we can always label it as A, you know, that's the area. So we can use A, all right, equal to the integral from 0 to 3 to x dx. But this is not necessary, you know, this is not necessary. What is more important is the method that you do it, you know, how to do it, the computation. But this is just for what? Intuition. So that you can imagine what actually we are finding. All right. So just sketch the graph so that we can see how it looks like. So if you have 2x, you know, very simple function. What is the integral? The integral is equal to 2x squared over 2. Now, you don't need the c, okay? Because we know that the c will at the end cancel out. So therefore, when you do the definite integral, we don't have to compute that, because you know when you do at that point, the c will cancel out. Okay, so for definite integral, you don't need the c. But if you do that c, it's fine also, you know, because at the end it will be canceling out. But for that indefinite integral, we need that c. So it's 2x squared over 2. You evaluate from 0 to 3, and of course that we cancel out. So what is it? It's equal to 3 to the power of 2 minus 0 squared. That is equal to 9. So the area or the value of the definite integral of 2x from 0 to 3 is equal to 9. And what is it? It's the area under the curve y equal to 2x between 0 to 3. Okay, all right. Now, when you look at area, what is the unit for area? This is just to review the unit for area. What is the unit for area? When you have area, what is it actually? What is the unit for area? Anybody recall? If you find area, of a land, area of a land, in let's say